Good morning, fifth grade. Today we are in lesson 5 on page 37, and we are getting an understanding of place value in a hands-on way. Let's go to draw it. Draw it. Use models to describe the relationship between the value of the digits in the decimal 0.77 and their place value position. Number 1, use models. Shade the model to show 0.77. Write the decimal in word form and standard form. So if we were to shade that area, "77 out of 100 boxes are shaded in." In word form, that would be 77 hundredths. In standard form, 0.77. The place value chart that you used for whole numbers can be extended to include decimals. Right? Here are the tens and ones. In the ones place would be 0.77, 77 hundredths. Number 2, describe the relationship. The value of the digit 7 in the tens place is 0.7, or 7/10. The value of the digit 7 in the hundreds place is 0.07, or 7 hundredths. Use a calculator to find 0.7 divided by 0.07. If I were to divide 0.7 divided by 0.07, I would get 10. Now, the reason that is important is because the value of the digit 7 in the tens place is 10 times greater. And we have learned this with place value before, that the digit to the left is always 10 times greater than the digit to its right, the place value to its right. And the same holds true in decimals, right? The tens place is 10 times greater than the hundredths place, which is 10 times greater than the thousandths place. The value of the digit 7 in the hundredths place is 1/10 times as great as the value of the digit 7 in the tenths place. Try it. Describe the relationship between the value of the digits in the decimal 0.027 and their place value position. Number 1, use the place value chart. Write the decimal in the place value chart. Now, while looking at the model, I can see that this is a thousandths cube, that it's not just hundredths in front, but it goes 10 deep back. So the 27 squares that are shaded are 27 thousandths. Therefore, the decimal should have 27 in the thousandths position, the last digit in the thousandths position, and the zeros come before. Describe the relationship. The digit in the thousandths place is 7. It has a value of 0.007 because it is 7 in the thousandths place. If this digit were to move to the hundredths place, it would have a value of 0.07, which would be 10 times greater. If this digit were to move to the tenths place, it would have a value of 0.7, which would be 10 times greater still. The digit in each place has a value that is 1/10 times as great as it has in the place to its left. Talk about it. The decimal model shows 0.033. Right? It's out of thousandths. The last 3 is in the thousandths position. Use this decimal to answer exercises 1 and 2. What is the value of the 3 in the hundredths place? So we're talking about the 3 here. We're talking about the 3 here in the hundredths place, not the thousandths place. That 3 has a value of 0.03 or 3/100ths. What is the value of the 3 in the thousandths place? In the thousandths place, the 3 is 0.003 or 3/1000ths. The decimal model shows 0.033. Use this decimal to answer exercises 3 and 4. How much greater is the digit in the hundreds place than the digit in the thousandths place? Always, the answer to that question is the same. The digit in the hundredths place is 10 times greater than the digit in the thousandths place. Number 4, use number sense. How many times as great is the value of the digit in the thousandths place as in the hundredths place? Oops, we're going the other direction now. So for this one, it is 1/10 times as great. Okay, guys, that concludes your direct instruction for today. Go on to independent practice. See you soon.